Hello, everyone, and welcome to your channel of Math Made Easy. Um, Today, I will start this session that I should have started earlier about matrices. So I worked with matrices before in Gauss-Jordan elimination method, how to invert the matrix, assuming that everybody knows what matrices are. However, if you have trouble with those, or if you haven't covered matrices first, so let me give you a quick introduction to them. Matrices are basically rectangular objects that contain numbers. So we refer to them with an uppercase letter. So I can say A equals, and then we use brackets or big parentheses. So either brackets or parentheses. And we say here, for example, A11. The first letter refers to the row number. This is a row. The second number refers to a column number. So I have A12 because it's the first row, second column, A13, for example, and then A21, A22, A23. So that we refer to it as a 2 by 3 matrix. We always write the number of rows first, then the number of columns. So A23, of course, 2 times 3 is 6, so it has 6 elements. Notice that we refer to the matrix with an uppercase letter and with an individual entries with a lowercase letter. Matrices can be added, subtracted, multiplied, but not divided. So let's look at the operations. Suppose I have matrix A that is any numbers 1, -3, 4, 2, and matrix B is -2, 4, 6, and -1. And I want to tell you what is A plus B. Before we can add two matrices, you have to understand they are of the same size. They have the same number of rows and the same number of columns. Whether you are going to add or subtract them, they have to have the same size. Okay? And now you are going to add, let's say, the first A11 with B11. 1 minus 2 is -1. -3 plus 4 is +1. 4 plus 6 is 10. And 2 minus 1 is 1. So very easy. Like you are adding all the respectively placed, like corresponding numbers and filling up so that, of course, would stay 2 by 2. If you say A minus B, you would say 1 minus -2 is 3. -3 minus 4 is -7. 4 minus 6 is -2. And 2 minus -1 is +3. Again, 2 by 2. So addition, subtraction are very easy. In fact, multiplying a matrix by a constant is also easy. So I can multiply A by 2 or 3 or -5. So for example, -2A, I would multiply each number by -2. So the 1 becomes -2, the -3 becomes +6, the 4 becomes -8, and the 2 becomes -4. Very simple addition, subtraction, multiplying by a constant. So far, so good? Great. Now, how about multiplication? Multiplication is different. Multiplication, if I have a matrix A that has sizes, let's call them m times n, like 2 times 3 or 2 times 2 or 4 times 1, whatever, okay? And I multiply it by matrix B, the operation is only valid if B has the same number of rows as A has columns. So these two numbers, the inner numbers should match. And let's say this is times R. It doesn't matter. The other two don't have to be the same. Okay? So if this matrix is C, meaning the product, I'm going to call it C, C would have as many rows as the first and as many columns as the second. So the outer numbers give me the new dimension or the new size only if the inner numbers match. Of course, if it's the same size, like 2 by 2 times 2 by 2, yes, I can multiply A by B. But what if I have a matrix, let's call it D, and matrix D was 2, 1, negative 3, 0, 4, 1. It's a 2 by 3. Here, I can multiply A by D because 2 and 2 match. I can multiply B by D because 2 and 2 match. I can multiply A by B because 2 and 2 match. But I cannot multiply D by A because this has 3 columns and A has only 2 rows. We said the inner numbers must match, meaning commutative law doesn't work for matrix multiplication, even if they are valid. Generally speaking, A times B does not equal B times A. In very rare cases, they are equal. Well, if one of them is a power of the other, meaning a square, if B is A times A, meaning A squared, then yes, A times B or B times A is okay. Or if I multiply A by the inverse of A, remember we mentioned the inverse before in when we were finding the solution of a system of linear equations. So the inverse of A times A is the same as A times the inverse of A. And both of them will give you I, which is the identity matrix that looks like that. If it's a 3 by 3, it looks like that. The main diagonal, which is the diagonal in which I have A11, A22, A33, and it's always going to be a square matrix. It has to have the same number of rows as number of columns. That's why we call it I3. We don't say I3 times 3 because it is square anyway. So it's enough to say the size of this is 3. Now let's take some examples, or just a quick example on a new matrix. Since we used A, B, and D, let's call, and C. So let's call this is E. And I'm going to show you something. Suppose this was 4, 1, 2, negative 3, 4, 1. It's a 2 by 3. And F is a 3 by 2. 6, negative 1, 2, 5, 1, 3. You'd say, oh, so here you can see I can multiply E by F because the inner number match, and the resulting matrix would be a 2 by 2. Or I can place the F first. I can multiply F by E because the 2 and the 2 match, and the resulting matrix would be 3 by 3. So E times F is 2 by 2. F times E is 3 by 3. That's a proof that they are not equal, right? Even though they are valid, the operation is valid, but it's not equal. So let's see how I perform E times F. We know that we will get a 2 by 2 matrix. Okay, I want to find, so if E times F, we call it G, G would be a 2 by 2. So this element would be called G11, right? It's G, first row, first column. This number refers to the row from the first matrix, and this number refers to the column of the second matrix. What do you mean? I mean, I will take, if I want element 1, 1, G11, I would take the first row of E and the first row of F and multiply them element by element, going from left to right or from the top down. So I'm going to say it's 4 times 6, 24, plus 1 times 2, 26, plus 2 times 1, 28. So this number is 28. How do I find the set A12? G12. G12. Where do I get the 1? Where do I get the 2? Yes, I get the 1 from the first matrix and the 2 from the second matrix. So I'm going to multiply this row by this column. That's why the number of columns here should match the number of rows there. So that if I have 3 columns, I have to have 3 rows so that when I multiply them, I get exactly the same numbers that I multiply. 4 times -1 is -4, plus 5 is 1, plus 6 is 7. Then element G2, 1. 2, 1. -18 plus 8 is -10 plus 1 is -9. Finally, G22, second row, second column, +3 plus 20 is 23 plus 3 is 26. So that's E times F. Excuse me. Now let's try F times E. That would be a 3 by 3 matrix. But now some people prefer to write this first so it's less confusing, but basically you are taking the first row of F and multiply it by the first row of E to get the first element. Let's call it H11, H11. First row, first column. 6 times 4 is 24. -1 times 3 is +3, so I get 27. First times second, I get 6 minus 4 is 2. First times third, 12 minus 1 is 11. Then I move to the second column. Second and first. Second and first. 8 minus 15 is -7. Second and second, 2 and 20, 22. Second and third, 4 and 5 is 9. And finally, I finish the last row. First and first, 4 -9 is -5. First and second, 1 and 12 is 13. Last one, third and third, 2 and 3 is 5. And here you do the multiplication. It's very easy. Take the row from the first matrix, the column from the second matrix to find the element row column. Okay? Now, one more thing probably before we, or maybe a couple of things. Let's say if I have a matrix, let's call it A since it's a new page. And A, for example, is 2, 1, -3, 4. I can find the transpose of A by making the rows column and the columns rows. So if this was a 2 by 3, the transpose would be a 3 by 2. Why? Because I'm going to take the first row and write it as the first column, the second row as the second column. And now A and A transpose are just, if I take the transpose of A transpose, I will get A back. Okay, so the transpose of the transpose will give you the original matrix. Of course, since this was a square, I ended up with the same thing. It turns out that if I have two matrices like A and B here, and I ask you to find the transpose of the product. So let's say, let's make another B. B here is 4, 2, -3, 2. Then B transpose would be 4, 2, -3, 2, right? Mathematically speaking, if I want to multiply A times B and then take the transpose of the product. So after I multiply, I'm going to make the rows columns and the columns rows. Well, I can do it by multiplying B transpose, that second one, times A transpose, the first one. Let's check. What is A times B? That shouldn't take long. A times B. So this first element is first row times first column. 8 minus 3 is 5. And then first and second, 4 and 2 is 6. Then the second and the first, so you get negative 12 minus 12 is negative 24. And then second and second, I get negative 6 plus 8 is positive 2. So this guy, A times B transpose, would be 5, 6, negative 24, 2. Now let's do B transpose times A transpose. That's also going to be 2 by 2. First times first. 8 minus 6 is 2. Something is wrong. No, I'm sorry. B times 8. We said B. First times first. So 8 minus 3 is 5. This guy would be first times second. Negative 12 minus 12 is negative 24. Second times first. 4 and 2, 6. Last element. Second times second. Negative 6 plus 8, 2. Identical. Okay? I think that's enough for as an introduction for matrices, because next time I will go quite deeper than that and work examples that you will understand would make life easier for you later in linear algebra. Thanks for your time and hope to see you soon. Bye.